Hello and welcome to my science tutorials. In today's video, we want to look at collinear points using the slope or the gradient formula. So without further ado, let's begin. Now in our previous video, we did look at what collinear point is. We said that collinear points are any points that can be found on a straight line. So assuming we have this straight line, so let's say we have a point here, say point A, we have another point here, point B, and then another point here, point C. We say that these 3 points are collinear points because they are found on a straight line. Now, to be able to identify if 3 points are collinear points, there are 3 different ways we do that. We can either use the distance formula, which we saw in our previous video. The second way to do that is to use the slope or the gradient formula. And then the last way to do that is to use the area of a triangle approach or formula. Alright, so in this video, we'll be looking at the second part, which is the slope or the gradient formula. Now, if 3 points are collinear points, it means that the gradient of any of those 2 points should be the same. I take that again. If let's say the points A, B, and C are collinear, then the gradient of any of these 2 points should be the same. So it means if I calculate the gradient of, let's say, point AB, it should be equal to if I calculate the gradient of point BC, and it should be equal to if I calculate the gradient of AC. So if the gradient of AB is 1, then I expect the gradient of BC to also be 1, and then the gradient of AC to also be 1. Alright, so this is how we find whether 3 points are collinear or not. Now, just a little recap. To find the slope or the gradient of 2 points, which is given by m, this is equal to the change in the y-axis, which is y2 minus y1 over s2 minus x1. So this is basically the change in y-axis on the change in x-axis. So this is the formula for calculating the gradient of a line of any 2 given points. Alright, so let's look at an example. We are to show, using the slope formula, that the 3 points P 24, Q 46, and R 68 are collinear. Alright, so let's go ahead and look at the solution to this problem. Alright, so they're saying we should show, using the slope formula, that the 3 points PQ, so I have P 24, my Q 46, and then R 68 are collinear. Now, if these 3 points, if P, Q, and R are collinear, then the gradient of the point PQ, that is P and Q, if you find the gradient of these two, it should be equal to if you find the gradient of Q and R, and it should be the same if you find the gradient of P and R. Alright, so let's go ahead and find the gradient of each of these points. So the gradient of PQ will be equal to y2 minus y1 on x2 minus x1. So let me label my coordinates. So this becomes, since P is my first point, it becomes my x1, y1. This is my s2, y2. So my y2 is 6 minus my y1, which is 4, on my s2, which is 4, minus my x1, which is 2. So this gives me 6 minus 4 is 2, on 4 minus 2 is also 2, and this is equal to 1. So the gradient PQ is 1. Alright, so let's go ahead and calculate the gradient for QR. The gradient for QR will be y2 minus y1 on s2 minus x1. Alright. Now in this case, because now I am looking at Q and R, my Q becomes my first point, so this becomes my x1, y1. This becomes s2, y2. Okay, so it means that my y2 over here is 8 minus my y1, which is 6, on s2, which is 6, minus x1, which is 4. So this is equal to 8 minus 6, that will give me 2. 6 minus 4 will also give me 2, and this is equal to 1. So already we can see that the gradient of the point PQ and the gradient QR are already the same. So let's confirm the last one, which is the gradient of the points P and R. So the last one, the gradient of PR. So in that case, our gradient will be y2 minus y1 on x2 minus x1 as usual. But this time around, let me erase this. This time around, because we are starting, our first point is P, it means that this becomes our x1, y1. Alright. So from here, we have my y2 is 8 minus my y1 is 4 on my s2 is 6 minus my x1, which is 2 over here. So this is equal to 4 on 4, and this is equal to 1. So we can see that the gradient of the point PQ is 1, which is equal to the gradient of the point QR, which is also 1, and which is equal to the gradient of the point PR, which is also 1. So because the gradient of PQ is equal to the gradient of QR, which is equal to the gradient of PR, we say that the three points P, Q, and R are collinear. So you can end your question by writing this statement to show that yes, because this is 1, this is 1, and this is also 1, the 3 points are collinear. Alright, so let's go ahead and have a look at another example. So if A with the coordinate 5, 2, B 3, negative 2, and C 8, 8 are 3 points in a plane, check whether the points are collinear or not. Alright, so let's write down our solution. So you can go ahead and try calculating the gradient for the point AB, BC, and then AC to see if you will get the same answer for the gradient. Alright, so let's go ahead. So I'm going to write my points A 5, 2, my B is 3, negative 2, and then my C is 8, 8. As usual, I say if A, B, and C are collinear, then it means that the gradient of the points AB should be equal to the gradient of the points BC, and that should be equal to the gradient of the point AC. So the first thing I do is to calculate the gradient of my points AB. So for my point AB, this becomes my x1, my y1, my s2, y2. Okay, so my formula is y2 minus y1 on s2 minus x1. So this is equal to my y2 is negative 2 minus my y1, which is 2, on my s2, which is 3, minus x1, which is 5. So this is equal to minus 4 at the top on 3 minus 5 will give me minus 2, and this cancels this, so I have here 2 as my gradient over here. Alright, so let's go ahead and calculate the gradient of B and C. Okay. So for the gradient of BC, this is equal to y2 minus y1 on x2 minus x1. Because B is our first point, it means that this is my x1, y1, s2, y2. So this is equal to, my y2 is 8 over here, as you can see, so I have 8 here, minus my y1 is minus 2, so I have minus 2, on my s2 is also 8, minus my y1 is 3. So this is equal to, at the top I'm going to have 8 plus 2, and that will give me a 10. On the bottom here, 8 minus 3 will give me a 5, and 10 on 5 will give me 2 as my answer. Alright, so let's go ahead and calculate the gradient of the last set of points, that is A and C, to see if we'll get the same result. So the gradient of the point AC is equal to, for AC, my A becomes my first point, so I have y1, x1, y1, and then x2, y2. Alright, so I can go ahead and quote my slope or gradient formula, which is y2 minus y1 on x2 minus x1. So this is equal to, my y2 is 8 minus my y1, which is 2, on my s2, which is also 8, minus my x1, which is 5. So I have at the top over here 8 minus 2, that will give me 6, on 8 minus 5, that will give me a 3, and 6 on 3 will give me 2. So therefore we can conclude that the point A, B, and C are collinear, since the gradient of any 2 points, let's say the point AB is 2, point BC is also 2, and point AC is 2. Since the gradients are the same, the points A, B, and C are collinear points. So thank you so much for watching. This is how we use the slope or the gradient formula to find if 3 points are collinear points on a straight line. Now in the next video, we'll be looking at how to use the area of a triangle formula to find if 3 points are collinear or not. So thank you once again for watching, and I will see you in the next video. Bye bye.